another name for Skynet.
Hi, I'm Jess. I'm from the University of Tasmania. I'm a first-year PhD student, and I'm also working with the CSIRO ICT Centre, which isn't called the ICT Centre anymore. It's called the Intelligent Sensing and Systems Lab, which sounds much more impressive. Okay. So my PhD topic was initially in cloud robotics, and when I proposed this talk, it was about cloud robotics, but I have since changed topic, so I haven't actually done a whole lot more. So it's a little bit shorter than I intended it to be, because I thought I would know more by this point. So the main issue with cloud robotics is that it is a buzzword, and anyone who does anything that involves the cloud and robots uses the term cloud robotics to describe it. So if you search for cloud robotics, you get a huge range of things that may not necessarily impact anything that you're doing. So I came at this from an environmental monitoring side, because the work I've done previously has been with sensor networks and mobile phone sensing and things like that. So I will look at it from a slightly environmental monitoring point of view, but there are heaps and heaps of other things that I'm probably not going to cover here. So the concepts behind cloud robotics have been around for ages. Like back in the 90s, there were internet-enabled robots, but having the cloud now creates easy ways for people to do it, and there's a lot more bandwidth these days. It's actually practical to have your robot connected to the internet and having most of its processing being done somewhere else. So there is a few issues with connectivity. You can't expect your robot to always be able to be connected to the cloud. A lot of the work that the Tasmanian ICT Centre does is with underwater robots, which don't actually communicate very well underwater. So they have to actually surface to be able to communicate and get GPS and things like that. So being able to have their processing done somewhere else isn't actually very useful for them, because they would have to keep surfacing every now and again to get the information that they needed. So what exactly is the cloud? Most of us have probably used the cloud at some point. It is dynamically scalable resources available as web services, I believe, is the definition. So it's pretty much web services you can use. You can make them big, you can do small things. And cloud robotics is sort of run with this and has gone, you can do anything with the cloud. So there are lots and lots and lots of things that come under the banner of cloud robotics. So the main things I was looking at was incorporating the sensor web and sensor data with cloud robotics. But there is a huge range of things, from simply offloading processing to robot as a service, which is one of those lovely X as a service things, which is obviously a cloud thing because X as a service is cloud. So robots as a service is sort of remote control robots as a service, which is kind of cool. So if you don't have a robot, you can just borrow someone else's.
That's very good.
Yeah, sounds like a good idea to me. Also, if you're somewhere far away from your robot, you can use the service to control it. But there's also lots of other things, processing, decision-making, and things in the cloud don't necessarily have to be computing power, they can be people power. So if you have problems where you want to identify something in an image that your robot is looking at, you can use things like Amazon Mechanical Turk and say to people, what is this? And they can return the information, and you don't have to worry about programming that stuff. So why do we even want to use the cloud? It obviously has some lag issues. If you're trying to do real-time processing, it's not very useful because communication's not always available. But because you have all this power in the cloud, all the computing power, you get more autonomy. You can do more things, and you're not increasing the size or the power consumption of the actual physical robot, which is a huge issue. You don't want a giant robot that's trying to do something delicate. You want to keep it as small as possible so it's using the least amount of power. So using the cloud is very good in certain situations. So generally what I'm going to do now is go through lots of different examples that I've found that were interesting. There's lots of examples that aren't very interesting. I might talk about them, maybe not, if I get distracted. So the first thing people think about when they think cloud robotics is robot as a service. As I said before, is remote control of a robot, and there is a framework for doing this, which is in that paper, which is using the Robot OS, which is fairly common, at least with all the stuff with robots I've seen, people have been using RoboOS. So robot as a service is useful if you have a robot that's, just doing something, but it's not doing something very, intensive. So, you might have a robot that's out in the rainforest, it's taking some environmental readings, but it has a lot of free time. But someone somewhere else may also want to know readings from that area of the rainforest, and they don't have the resources in order to have a robot to actually deploy there. It does actually take a lot to have a robot deployed. It costs a lot of money, and it is difficult. So you can make your robot available. These other people can then use the robot to do things that they want to do, and everyone's friends and everyone's happy. And so this can be a sort of remote control thing, or it can be a tasking thing where you say, I'm also interested in this information, can you give that to me? So NASA does a lot of that stuff with their Earth Observing 1 spacecraft. You register goals, so you might be interested in floods in a certain area. If their satellite sees that, it'll then go, this person wants to know about that stuff. I'll collect this information for them. Just kind of nifty, but I think you have to be a bigwig science person to actually get access to that stuff, which makes me good sense. So that's robot as a service. And very similar is service robots, at least in name. So service robots are robots that work with people, they assist them, so normally the elderly, disabled, that sort of thing. And creating a robot for one certain purpose is good, so you might have a robot that helps you around the house, but that robot's not very useful if you get in the car or if you go to the bank. They don't have any idea what's going on, essentially. So these people created systems where a robot working in an uncertain environment can get information about that environment if other robots have been there before. So if you were to take your little house robot to the bank, it can say to this service, oh God, where am I? What am I doing? I don't even know where to step, kind of thing. It can't see the terrain. It can get all this information and then actually be useful. The first paper also talks about mobile phones as robots, so virtual robots that has artificial intelligence that will probably help you in certain situations. It can't actually affect anything, but it can sense things for you and give you information. So another part of this service is finding other robots that can help you in certain situations. So your robot may be completely crap at the bank, but the bank has its own service robot. So it can say, hey, I'm here, I have this person, do you have a robot available to help them? That sort of thing, and that can happen from your phone. So the second paper is a little bit more about transferring context of the person that you're looking after. They have this nice story of the future when someone has a heart attack in the car, and the car can tell the hospital that this is all the information about this person, etc. So it's about being able to hand a person to a different robot and be able to transfer all the information they have to the next robot and say, this is this person, this is what's wrong with them, this is what you need to do, etc. So they're not just like, hey, it's a person, and wander off, and this person who has a walking frame is going, oh God. So, and that's very useful for things like that. It makes the robots more useful, essentially. Because you don't want useless robots. That's just it. So this is falling a little bit more into what I was doing. So when you have sensor networks, you normally have a large amount of you have a certain amount of robots working together, collecting information, and they would often have the ability to transfer some of their processing to their neighbours. So if they were doing really intensive things, someone over there might not be doing something too intensive, so you can say, hey, can you process this for me? So this is kind of like the cloud, except you're using your friend instead of that guy over there. So these people tried to find ways that the cloud could be easily integrated into these systems. So they worked on the basis that in the cloud you would have robot simulations. So in the cloud you would have a whole collection of robots that could do work. And they tried to find the easiest way to integrate it into systems they already had. So they tried using one gateway to the cloud. So you would have one robot in your network which would then talk to the robot network in the cloud. And so all the processing would be passed to this one robot, which would then pass it to the cloud if necessary. Which was good for the general physical network, but wasn't very good if you lost that cloud connection, because you had that one point of failure, you lose that, and then suddenly you're working without half your network. So they then tried with a couple of different robots that were connected to the cloud, which worked well, and it worked well within, you only needed to replace the software for a few robots, and maybe even hardware, because your robots may only be able to communicate with things near them, they may not have a 3G connection, that sort of thing, so you may actually have to change your robot entirely to make it be able to talk to the cloud. So they did that, and yeah, that's good, but it's not very mobile, I think, was the issue with that one. If you move away from your network, then you don't have a connection to the cloud, etc. So they then tried clone-based architecture, which I think is really cool having. So each robot then has a connection to the cloud and a clone of itself in the cloud that it's connected to. So this robot then is entirely integrated with the cloud. It thinks the cloud is itself, essentially. Which means it's good for the network, because in the cloud you don't have to be near the simulated robot because it's software, you're there. So the robots then had a connection to the robot that was furthest away from them with one hop kind of thing. But again, this wasn't very interoperable with what they had before. This means you have to replace or modify all your robots, which could be a big deal if you have a huge selection of robots that you are actually using. This is my favourite, RoboEarth. This actually started before the Cloud Robotics term. So if you search for Cloud Robotics, you probably won't find RoboEarth, but it's one of the best examples, I think. So RoboEarth is about building a structured representation of the Earth using robots. So robots work in an environment, they map the environment, they do actions in an environment. So RoboEarth allows them to upload all these maps, all these things that they've done as recipes. So when another robot comes into the area, they can say, hey, I'm here, what does it look like? What have people done in the past? And so if they need to do something, they can then very easily learn how to do that thing from the other robots that have come before them. The main issue with RoboEarth is robots aren't very good at classifying what they're doing. So when they're actually uploading these recipes, I went over here and I picked up this glass, they may say, they picked up the glass, but the next robot that comes along goes, hey, I need to grab that glass. Goes, how do I grab a glass? And goes, oh, no one's done that before. So there is that huge sort of disconnect between how do you describe things and how do you store them, how do you get them back. Also with this, when a robot does something, it's generally very strongly tied to the way it is physically. So it's embodiment. So the way that one robot does something can be completely different to the way another robot does something. So if it comes along and grabs the recipe and goes, whoa, I don't have arms, and I can't use it. So there's a lot of work with being able to annotate things in a way that doesn't remove the information that was there before. So that if another robot comes along that does have arms, it hasn't then lost the information from that recipe about what to do if you have arms. But I think this is really cool. This is kind of getting to the scary level of robots knowing everything about everything. But there are obviously these huge holes in this representation, because there are areas where lots of robots work and there are areas where robots would have never gone. I watch, I found under the desk. So the use of people within the cloud is also really cool. So people think differently to robots. They have different skills, they have experiences, they have knowledge that robots can't easily attain. So particularly with computer vision things, a lot of the examples of this stuff is with grasping. So a robot comes along something, how does it actually grab it? What does it look like? So this is using things like the Amazon Mechanical Turk that I mentioned earlier. So you upload the robot might come along and go, what's that? Take a picture of it, upload it. Someone is given this, says, what is it? Can you just map it a little bit, give us a few points and say what it is? And then that gets sent back to the robot. The robot goes, that's what that is. I can now pick it up. There was one example of this happening with an office. There was a robot working within an office, and they were sort of just training it to recognise people. And so it would work within the office. They said to the office people, just go about your business. Ignore the robot. So they were doing this, and when they went to actually look at all the images that people had taken, and then people had gone through and mapped out all the people that were in these pictures that the robot took, they realised they couldn't actually use most of it because all the pictures were of people taking pictures of the robot. So there was only like 25% of the photos that were actually useful for training the robot to recognise people. So robots aren't quite ready for people yet, maybe. So, and this means that there's a lot of sort of, you don't need to worry about coding things that are difficult necessarily. You can just get people to do it. It's like the man behind the curtain. Cool, I've sped through that. So Cloud Robotics is opening up a huge world of things for robots, for autonomy, and for... No comment, Chris?
No.
Okay. So, for autonomy particularly, being able to process large things without actually increasing the size of robots. Any questions? Yes?
What sort of protocols do you sort of use to network your robots together at the moment? Are you using sort of Zigbee-based stuff, or?
I haven't actually really worked with robots physically. A lot of the stuff I've done in the past has been Bluetooth communications between sensors and things like that. So a lot of it is moving towards Zigbee these days, and I know there's quite a few larger networks that use Wi-Fi and stuff like that, but generally for cloud you'd be using 3G.
So what's your research?
My research has moved into autonomous science and hypothesis generation. So it's pretty much... It was originally looking at ways that robots could do science within networks, but it's moved to actually using the data that's collected within the sensor web to generate hypotheses, which can then be given to robots to do experiments. So not actually working with the robots themselves, which is a little bit sad. I was all excited.
Any other questions?
What kind of data do you find is most interesting? Like what sort of data is most used in research when looking at sensory?
Well, it really depends what you're doing. The stuff that I mainly work with, I've worked with in the past, has been water meter data. So looking Bluetooth sensors to water meters so people can actually look at when they're using water and how much at different times of the day and stuff like that. But I've also made weather stations with like wind stuff. Generally the stuff I work with is weather, that kind of stuff, but yeah, I have done some urban sensing stuff. Yeah, water meters, and we did one thing where we were monitoring the air inside meeting rooms because people were complaining about it getting really hot and like passing out in meeting rooms because people were talking too much. So we actually, it's my supervisor, I'm going to blame him. So we set up lots of sensors inside the meeting rooms to actually look at the CO2 levels and temperature within the meeting rooms, and it was actually quite scary how quickly it would get pretty gross in there.
Other questions?
Okay.
Well, on behalf of everyone here, I'd like to thank you for a great talk. And we have
Oh, chocolates!
lots of chocolates for you.